Good morning. Today we will learn about block 11 of class 7th, that is angle pairs. Here, first of all, we should revise some basic geometrical ideas of our geometry, right? This is point. We represent it with any capital alphabet, suppose P. Point has no dimensions. It is representing a fixed position. Point is representing a fixed position. Then comes a line segment AB. AB is a line segment with the symbol AB and bar over it. It has two endpoints and has fixed length. Then comes a ray. One endpoint is fixed, but one end is extended over here. It has only one endpoint. We can represent a ray with one-headed arrow. Fixed point is on the side where it is fixed, and the arrowhead is on the side where it is there in the diagram. If I have to represent a line, I will represent it with two-headed arrow. Again with the capital alphabets and a two-headed arrow. Line is extended infinitely on both the directions. So it do not have any fixed length. It do not have any fixed point. Do not have any end point. That's why this is line, this is ray, line segment and point. This was the basic thing, right? Now we have learned about angles in the previous chapter. These are the angles, right? Where lines and angles can be formed in our daily life. We can say this is the line segment, the length is fixed, right? This is the line segment. The edges of our door, the edges of our windows, tables and all. In our daily life, in our classroom, in our home, at our home, we can find out various examples having lines and angles, right? If I am taking example of a tabletop, this is an angle formed by a tabletop. This is the line segment, this is the line segment, right? So, how many types of angles are available here? Types of angle. How many types of angles we have learned so far? Types of angles. First, acute angle, as we all know, whose measure is less than 90 degree. Less than 90 degree, right? It can be represented like this. Angle AOB is equals to, suppose 60 degree, and 60 degree is 90 degrees or less. So it is an acute angle. Obtuse angle. Obtuse angle is more than 90 degree. More than 90 degree, right? So if I'll convert this, angle AOB is equals to 120 degree. That means it's a more than 90 degree. It's an obtuse angle. It is an obtuse angle, right? Right angle. What is right angle? Whose measure is exactly 90 degree. Whose measure is exactly 90 degree. Then comes straight angle. Straight angle, whose measure is 180 degree. Straight angle because it's making a straight line. So angle POQ. Angle POQ whose measure is equals to 180 degree. That means it's a straight angle. Then comes reflex angle. What is reflex angle? More than 180 degree. See, this was 180 degree and this is something more than 180 degree, right? So, angle X, Y and Z is more than 180 degree, suppose 230 degree, it will be reflex angle, right? This is a reflex angle. So, these are all the types of angles which we have ever done. Now, if I give you 2 or 3 situations to draw, you know how to draw a line now? If I tell you draw a line, the pair of lines which meet, draw two lines which meet at a single point. So how I am going to do that? This is line L, this is line M. If I am representing a line with the small alphabets, then I don't need at other end. This should be line L and this should be line M. If instead of this, if I am representing this with the capital letters, so I need both ANDed figures. So this is line AB and this is line CD meeting at point O. And point O is the point of intersection where these two lines are intersecting. This point is the point of intersection. Is that clear? Now, if I'll give you the second condition, that draw two lines which are meeting each other at a single point, but the point is exactly at 90 degree. The point of intersection frames a 90-degree angle between these two lines. So how I am going to frame that? This is 90-degree angle. This is X, Y, P, Q. So X, Y and PQ are the two lines that are intersecting each other, but the only condition is they are intersecting at a 90 degree. Is that clear? Now, if I tell you to draw two lines which are not at all going to meet ever, they are never going to meet, how you are going to frame that? This is called parallel lines. Suppose I'll write L and M. So L is parallel to M. This is a symbol of parallel lines. L is parallel to M. Now, what about these? What about these? What these lines has been called? These are called intersecting lines. These are called intersecting lines. Intersecting lines which are intersecting at this point. This is called the point of intersection. What is this? This is called intersecting line, but intersecting at especially 90 degree. So it is called perpendicular lines. Perpendicular lines. Perpendicular to each other, right? We can represent like this also. PQ is perpendicular to XY, or XY is perpendicular to PQ, one and the same thing. This is a symbol of perpendicular, right? What these lines called? These lines are called the parallel lines. These are called parallel lines. The symbol of parallel line is this. L is parallel to M. What are the parallel lines? No matter how much you are going to extend them, they will never going to meet, and the distance between them remains same throughout. The distance between them remains same throughout, right? What is a real life example of this parallel line? We can see on the railway tracks, right? So railway tracks is a practical example. Two edges of our scale, for example. So these are the example of parallel lines. Is that clear to you now? Now, before moving ahead, I am going to ask you one more thing. What is adjacent angle? Which we have learnt already. What is adjacent angle? Adjacent angles are the pair of angle. Basically, adjacent angles are those pair of angles which are just next to each other, having one vertex common and one arm common, right? So, if I tell you two neighbors, if you and your neighbor are living next to each other, suppose this is your house and this is neighbor's house, they have one vertex common and one arm common, and the non-common arms are on the, one non-common arm is on the left side and one non-common arm is on the right side of the common arm. So these are called adjacent. Suppose, see here, this is the pair of adjacent angle. How? This angle and this angle having this vertex common, and this line which is common to this angle and this angle also. This line is common, one vertex in common, one line is common. Moreover, the non-common lines are one on the left side and one on the right side of the common arm. Is that clear? So the adjacent angles are just next to each other, having one vertex in common and having one line in common. Is that clear? One arm in common. Is that clear? Now, if I'll ask how many adjacent angles are there in this figure, how many adjacent angles, the neighboring angles are there? See, this angle and this angle, one pair are next to each other, having the common vertex and a common arm. Similarly, this and this, second pair, this and this, third pair, and this fourth. There are 4 pair of adjacent angles in first figure. How many are there? Similarly, these 2 are adjacent, these 2 are adjacent again, these 2 are adjacent, and again these 2 are adjacent. So there are again 4 pairs of adjacent angles. 4 pairs of adjacent angles. How many pair of adjacent angles are there? There are not a single pair of adjacent angle. Why? Because they are never going to meet. For being an adjacent angle, they should meet at a common vertex. They should have one arm in common, and these parallel lines are never going to intersect each other, never going to meet each other. That's why they don't have a single pair of adjacent angle. Is that clear to you? Now, what are pair of angles? What are the pair of angles? The pair of angles are those pairs which are related to each other in a special manner. Pair of angles are the pairs which are related to each other in a special manner. Special manner, we can say, suppose the adjacent pairs, adjacent angle pairs. That means the both angles should have something in common, having a common vertex. This is a special thing about them, right? So we have to learn more about the angle pairs. We have supplementary angles. Supplementary angles are the angle pairs whose sum is 180 degree. This angle 1 and this angle 2. If I add angle 1 and angle 2, the sum is 180 degree, are called a supplementary angle. So this pair of angle is said to be a supplementary angle. Is that clear? Is that clear? Supplementary angles. Now, this can be a supplementary pair example. This can be an example of a supplementary pair. Special case, both of the angles are 90 degree. Right? So these are the supplementary angles. If we can say, they are called the linear pair also. They are called the linear pair. Linear pair is angle formed on a straight line. Angles, the pair of angles form on a straight line. Angle 1 and angle 2, whose sum is 180 degree because they are forming on a straight line. So it can be called as a linear pair also. Is that clear? Now comes the complementary angle. Now comes complementary angle. The pair of angles. The pair of angles whose sum is 90 degree. Whose sum is 90 degree. This is angle 1 plus angle 2 together forms a 90 degree is called the complementary angle. Is called the complementary angle. So the angle pairs which add up to 180 degree are called supplementary angles, and all the linear pairs are supplementary angles. Is that clear? Now complementary angles are the angles which add up to 90 degree. Add up to 90 degree. Now, if I have these two markers with me, right? If I'll cross them here like this, if I'll cross them like this, how many angles they are forming basically? If I'll paste it over here, how many angles they are forming? They are forming 1, 2, 3 and 4 angles. This is one angle, this is second angle, so as 3 and 4. So they are forming 4 angles. Suppose this, angle 1, angle 2, angle 3, angle 4. Right? Is there anything special about these angles? Is there any relation between these angles? Is there any angle pair existing in between these angles? Now see, angle 1 and angle 3, if I measure with the help of protractor, always angle 1 is equals to angle 3. The measure of angle 1 and angle 3 is always equal, doesn't matter how I have intersected. Doesn't matter how I have intersected. doesn't matter how I have intersected, right? So this angle is equals to this and this angle is equals to this. Suppose this is angle 1 and this is angle 2, both should be equal. This is angle 3 and angle 4. Right? So these are called the vertically opposite angle. Vertically opposite angles are always equal in measure. So angle 1 and angle 3 are always equal, so as angle 2 and angle 4. If we measure these angles, they are forming the vertically opposite angle. Whenever the two lines are going to intersect with each other, they form vertically opposite angles. And that vertically opposite angle is for sure equal in measure. Angle 2 is equal to angle 4 because they are vertically opposite angle. Vertically opposite angles. In short form, we can write vertically opposite angle. Is that clear? Doesn't matter how they are going to intersect. If they are intersecting, that means they are forming a pair of vertical opposite angles which are for sure equal in measures. Right? Now if I ask, how many vertical opposite angles are there in this figure? If I have to analyze this figure, how many vertical opposite angles are there? Do you have any idea? Do you have any clue? According to me, there is not a single pair of vertical opposite angles available over here. Why? For being vertical opposite angle, there should meet the two straight line segments or lines. Two straight lines or two line segments. Here, the intersection point is that, oh, four angles are there, but they are not formed by the two straight lines. They are not formed by the two straight lines. So there is not a single vertical opposite angle. See, angle 3 is this much and there is no line extending like this. If it will be, it should be like this. Then 3 and this angle will be equal because they are made up of straight line. But here no straight line is given. That means there is no vertical opposite angle. In this figure, have a look. I will make it again. I will make it like this. Suppose this is x plus 15 degree, x plus 15 degree, this is 50 degree. For example, this is A and this is x. Right? Now we have to find only one angle is given to us, 50 degree. How we are going to find the rest, all the angles or value of unknown variables, that is x and A. See, this is 50 degree. These are the pair of intersecting lines which are intersecting at this point. So this 50 degree and this angle x will be equal as vertically opposite angle. So measure of x is equals to 50 degree because vertically opposite angles are equal. Right? What about this? What about this? Now x we got as 50 degree. So what will be the measure of this? This will be 50 plus 15 degree, 65 degree. So as the next one, this will also 65 degree. If we will add them up together, it is 130 degree. Together they form 130 degree. Right? What about A? A and this angle is vertically opposite to each other. So A is equals to 130 degree because vertical opposite angles are equal in measure. Right? Vertical opposite angles are equal in measure. That's why we are able to find the two unknown variables x and A. X is equals to 50 degree and A is equals to 130 degree. I am repeating it once again. Just have a look. 50 degree is given to us. X and 50 degree are vertically opposite to each other. That's why x value is 50 degree. Now I'll place this value in this equation. 50 plus 15 is equals to 65 degree. Again 50 plus 15 is equals to 65 degree. Together this angle is forming a vertical opposite angle with this A. So 130 degree is the measure of this angle. So as vertically opposite angle property, A is equals to 130 degree. See, it's somehow very difficult to grasp this concept that yes, vertical opposite angles are equal to each other. Although we can measure n number of times, every time we will be getting the same results. But still, there is a proof of vertical opposite angles. I am going to explain you over here. Proof of vertically opposite angles. Right? 1, 2, 3, 4. Right? Or we can say A, B, C, D. Angle A plus angle B is equals to 180 degree because they are forming a linear pair. They are forming a linear pair are on the straight line. So angle A plus angle B is equals to 180 degree. Is that clear? If I talk about B and C, angle B plus angle C is again 180 degree because of the same reason, linear pair. Right? Linear pair. So first we have taken this A and B. Secondly, we have taken this B and C. What if I equate these two equations? See, both are equal to 180 degree. A plus B, B plus C. Both are equal to 180 degree. Are they equal to each other also? Yes. So I can write angle A plus angle B is equals to angle B plus angle C. Angle A plus angle B is equals to angle B plus angle C. Now what next? What if I subtract angle B from both the sides? If I subtract angle B from both the sides, does it have any effect? Does it have any effect on the equity? No, because if we are subtracting the same amount from both the sides, left hand side of an equals to and the right hand side of the equals to, that means there is no effect on the balance or the equilibrium. So if I see B and minus B cancelled out, B and minus B cancelled out, here angle A is left and here angle C. Angle A and C are equal. This is what we have to prove. What we have to prove is vertically opposite angles are equal. So that angle A is equals to angle C. This we need to prove. And here in our result we have proved that the angle A and angle C are always equal with the help of the properties of angle pair, that is called linear pair. So that's all for today. Have a nice day.